Alright, in this video we're just going to look at determining the charges on transition metals when it comes to naming ionic compounds. Quick little review. Here's a periodic table. Our transition metals are the metals that are found, let's see, it won't let me write on here, but they're going to be found kind of in this valley here. So any of these, all the way up to our staircase that divides our metals from our non-metals. So if it's not in group 1 or 2, or if it's not the exception of aluminum, zinc, or silver, we're going to need a Roman numeral to determine the charge, because these elements' charges can change. Iron can have, any number of charges from +1 all the way up through +7 or 8. So we're going to look in how to do that. So for this, if we take a look at these examples, I've got Pb, which is lead, and lead's combining with nitrogen. So the way that we would write this is lead nitride. And I've left a big space here because I'm going to fill that space with a Roman numeral that represents the charge on my lead. So lead can take a number of different charges. We can't use the periodic table to find it. So what we need to do is ask nitrogen here. Nitrogen always has a charge of -3. So we're just put a little -3 as a reminder to ourselves. And there's 2 of them. So -3 times 2 should give us a -6 charge. We know overall this whole compound has a neutral charge. So what can we add to 6 to get 0? Well, that's a +6. Since there's 3 leads combining to add up to that +6 charge, we have to divide that 6 charge divided by our 3 leads. So 6 divided by 3 will give us a charge of 2, which means each one of those lead atoms will have a charge of +2. And the way we write that is little Roman numerals in parentheses between the first and last name. Let's try it again here. A little CO and CO3. A little different here that CO3s have to be recognized as one of those polyatomic ions. So CO, if you find it on the periodic table, is cobalt. And CO3 is one of those polyatomic, whoops, forgot the L in there. CO3 is one of those polyatomic ions we call carbonate. And if you look to your sheet of common ions, we're going to find that carbonate has a charge of -2. And be careful, that 3 is part of what makes carbonate carbonate. So we don't really think of that as a 3. That 3 isn't going to change this charge. We only have 1 carbonate here. If we had multiple carbonates, we would have to put that carbonate in parentheses, and then the number of carbonates outside of parentheses there. Since we only have 1 carbonate, and carbonate has a charge of -2, -2 happens to be my total negative charge. To balance that out, we have to have a charge of +2. So -2 + 2 will get me to 0. I only have 1 cobalt, so that total positive charge is going to be divided by 1 because there's only 1 cobalt. This is going to give us a charge of 2. So this would be cobalt 2 carbonate. Over here, a little bit different. Another transition metal, Cd, is cadmium. An ingredient in some rechargeable batteries. And SO3 is sulfite. Another one of these polyatomic ions. We only have 1 of them. Again, if there was multiple of these, we would put them in parentheses with the number of them that we have outside of parentheses. So the charge on sulfite is -2. We look that up on our chart, and we would find that the opposite of -2 would have to be +2. And we only have 1 cadmium, so 2 divided by 1. This just coincidentally happens to give us a Roman numeral 2 again. Let's take a look at this example here, copper, and then we've got NO2. NO2 is nitrite, so this would be copper, leaving space, nitrite. Excuse me. Here's an example. Nitrite has a -1 charge, but we have 2 of them, so 1 times, or -1 times 2 gives me -2. To balance that out, we have to have a charge of +2. And there's only 1 copper here, so this copper has to have a charge of +2.